Hello guys, my name is Nishan Jha and I'm doing a reassessment video for my Physics 221 class. I have a very interesting problem. I never came across this problem. It's a circular motion loop-the-loop problem. What the question says is that there is a ball of mass 2 kilograms which is released from rest at a vertical height of 10 meters above the ground. The ball then rolls down the incline and through a loop-the-loop of radius 2 meters. The path is an inclined plane, and then the ball rolls down. At the end of the inclined plane, there is a circular path, which is the loop-the-loop path. The question asks us to find the velocity of the ball at the bottom of the inclined plane, which is at that point, and it also asks us to find the normal force on the ball at the bottom of the inclined plane. For this problem, we're going to ignore the friction. So our free body diagram is going to look something like that. This is the initial position where the velocity is 0 meter per second, and that's the final, that's at the bottom of the path. To find the velocity of the ball at the bottom of the incline, we sum our potential and kinetic energy, and since it's a conservation of energy problem, the sum of potential energy and kinetic energy at the beginning is going to be equal to the sum of potential and kinetic energy at the final point. In our problem, the kinetic energy is going to be 0 at the top because it is at rest, and at the bottom it's also the potential energy is going to be 0 because there is no height at the bottom. Potential energy is going to be mgh, and the kinetic energy is going to be half mv square. We rearrange it and plug in the values, and then we get 14 meters per second. That's the answer for our final velocity at the bottom of the incline. Now the next part of our question is a little difficult to understand. It's asking us to find the normal force of the ball. Now the forces acting on the ball is going to be the normal force right there, and the mg, which is acting in the downward direction. But there is a trick here. We need to understand that the mg is not going to be equal to the normal force like any other problem we did. It is because it has a centripetal acceleration towards the center of the circle. Turns out the normal force is larger than mg. The way to understand this is the split second later, when the ball is like right there, it moves upward. It's now in a circular path and has centripetal acceleration that is pointing towards the center of the circle. We sum the forces to sum the forces, which is going to be the normal force mg acting on the negative direction is equal to mass times acceleration. Now this acceleration is the centripetal acceleration. Now we know centripetal acceleration is equal to v squared over r. So we plug it in, we rearrange everything, we plug in the values from the question. Mg 2 times 9.8 plus mass, which was 2 kilograms, velocity was 14 at the bottom of the inclined plane. We calculated that in the previous part of the question. We plug it all in, and then it turns out the normal force is 215.6 Newton. That's all for today. If you guys have any question, you can leave comment at the bottom or shoot an email. I'll be happy to answer. Thank you.